Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to use trigonometric substitutions to simplify down integrals that we otherwise wouldn't know how to do. So this one we're looking at right here, we're going to work through the integral 0 to 2 of dx over a plus 2x squared. And I always advise people this, an important thing is knowing when to use a trig sub. And I always advise that you try a trig sub whenever you're looking at something that reminds you of Pythagorean theorem. So when I look down here and I see this 8 plus 2x squared, that kind of reminds me of Pythagorean theorem. So I usually start by writing out that sine squared theta plus cosine squared theta equals 1. This is what I'm always going to use to help me choose the appropriate trigonometric substitution here. Now, as I look over here now, this is equal to a number plus 2x squared, or 8 plus 2x squared. If I take this equation and I divide both sides by cosine squared, this is going to become a tangent squared theta plus 1 equals secant squared theta. Now, tangent squared theta plus 1, x squared times 2 plus 8. This looks reasonably close to this. This means that a good start is going to be, maybe we're going to let x equal tan theta. However, when I simplify this down, I want this to read 8 plus 8 tan theta so that I can factor the 8 out and be left with 1 plus tan theta. So the substitution I'm going to use is let x equal 2 tan theta. And again, the reason, it's important to understand why this will help me out. Because x squared will now equal 4 tangent squared theta. When I take that 4, multiply by that 2, it becomes an 8. The 8 will be factored out, and I'll be left with 1 plus tangent squared, which is equal to secant squared. So this substitution should work. Now, when I do a substitution, we're also going to need the dx. Now, the derivative of tangent is secant squared, so dx is going to be 2 secant squared theta d theta. We also want to work on our limits. I'll write this one over here. If x is equal to 0, that's our bottom limit, this is now going to read 0 equals 2 tan theta. This has a solution of theta equals 0. And then if x is equal to 2, this is going to read 1 equals 2 tan theta. Or in other words, tan theta equals 1/2. Oops, I want to make sure this is right. I'm sorry. Not 1 equals 2 tan theta. 2 equals 2 tan theta. That's what I meant to say there. If x is 2, this is going to read 2 equals 2 tan theta. So tan theta equals 1, and this has a solution of theta equals pi over 4. So what we're going to do is rewrite the integral now from theta equals 0 to pi over 4. dx is equal to 2 tan theta. D theta, forgot the d theta there too as well. So dx is going to equal, oops, gotta back up here, sorry, dx is here, not here. 2 secant squared theta d theta, that's what I wanted. dx, 2 secant squared theta d theta. Divide by 8 plus 2x squared, so that's going to be 8 plus 2 times x squared. I'm going to go ahead and just write that 4 tangent squared theta. 2 squared being 4. Now, this is going to be integral 0 to pi over 4. I'm going to kind of glance it over for constants. We can bring a 2 out front. I can now factor an 8 out of this, and by the time I take 2 over 8, that's going to be a 1/4. Top is going to be secant squared theta d theta. The bottom is now 1 plus tangent squared. Now I'll take note that tangent squared plus 1 is equal to secant squared. So this is equal to 1/4. Integral 0 to pi over 4. Secant squared theta d theta over secant squared theta, and the the secants will go away for me. All right, so then we end up with 1/4. Now the integral of d theta is theta, evaluated from pi over 4 to 0. I'm sorry, 0 to pi over 4. So this is going to be 1/4 times pi over 4 minus 0, which is pi over 16. So there's the value of that integral. Again, you know, the big thing is using Pythagorean theorem, the trigonometric form of Pythagorean theorem, to make an appropriate substitution that will simplify your integral down. The way you choose the substitution, I always write out sine squared plus cosine squared equals 1. This will sometimes help me figure out what to choose. If not, if you divide this thing by cosine squared, you'll get tan squared plus 1 equals secant squared. And then just by comparing 8 plus x squared, or 8 plus 2x squared, 1 plus tangent squared. That was my clue that x equals 2 tan theta will simplify this thing down. Then you have to remember always to, when you make a substitution, you have to also change this, your dx, and your limits. I think I'll go ahead and stop this now and start my next example on a separate video. Have a great day.